So hey everybody, I'm Andrea Thomer. I'm one of the organizers of this session, and Doug Phils is my partner in graph crime, I guess. So thanks everybody for coming today. All right, we are supposed to start off by orienting you all to the technology. I think we've all figured out how to use Zoom at this point, I hope. I'm going to mute Simon as he's opening things. And the one other bit of technology that we'll use is Slido. So we're going to have a couple of speakers in this session, and as you have questions for them. So basically the session is organized as a panel, and then we want to leave plenty of room for discussion at the end. So as folks have questions during panel presentations, please enter them and upvote them here, and Doug and I will basically MC and ask them of the panel. Keep losing my notes. Okay, so as a reminder, by participating in the session, you agree to adhere to the ESIP community guidelines, which are here if you are not familiar with them, which is basically don't be a jerk. And ESIP is usually pretty good at not being jerks, so that I encourage everybody to continue doing that. Okay, so the goals of this session. I keep joking that I want to call this session, like in a Seinfeldy voice, what's the deal with community graphs? And the session originated because Doug and I keep seeing interesting projects related to graph-based data or graph formatted data in a bunch of different ESIP clusters. And we both have different kinds of questions about what's going on with these projects. So our goal today was to bring together some of those projects and to hear a little bit about them, and then open it up for community discussion. We are resisting the urge to say that we need another cluster related to graphs and graph-based databases. But instead, we are interested in trying to facilitate more conversations across clusters where this stuff is already happening. So some things that we're more specifically hoping for include like a feel for community. What is the community of knowledge graph developers here in ESIP? Who are the users, and what are the communities that are trying to use these and that actually need support? We're also interested in trying to develop and share within ESIP best practices or lesson learned with these projects, because a lot of them are getting developed in silos, and we'd like to facilitate some coordination across those silos. We want to identify areas for engagement both within and without of ESIP. So how could we reach out to, how can knowledge graphs be used to reach out to communities, and how can they be used to coordinate across groups? We want to identify future research and infrastructure development directions. A lot of these projects are grant funded, and I think there could be opportunities for some really cool collaborations going forward. And we're also interested in thinking about how do we get people up to speed and using knowledge graphs as a new kind of data format, new kind of technology. A lot of folks have been trained up in a tabular sort of universe, so working with relational databases, working with spreadsheets, and knowledge graphs are a very different way of thinking and a different way of setting up an infrastructure. So what do people need in order to actually get up to speed and using this different approach to building data and infrastructure? Doug, do you want to add anything?
Sure, I'll just add a couple things. If you look in the agenda, the notes for this session, in there are two sections that we kind of worked up. One was resources for this session. And in that, we're really just kind of providing an overview of the various types of graph approaches there are. So in this panel, I think it's really nice is that we have people working in Neo4j, we have people working in Neptune, so the Gremlin query language, the Cypher query language for Neo4j, and then triple stores and Sparkle and things like that. So we have a range of those. And if you're interested in those, inside that resources section, there are links out to those approaches, some of the data model information about how those graphs go together, and a little bit more information there. And then there's also one more little section below that called resources from this year's ESIP. We've had a lot of really good sessions already, and there are still more to come that I think are related to this idea of knowledge graphs, of community, semantic networks, elements like that. Obviously with the science and schema stuff that started out the work, and then all the way to the Wikidata session that's going to take place tomorrow, and a lot of really good stuff in between there by people who are in this session. So those links are in there for people to check out for other things that have gone on during this particular meeting.
Great, awesome, thank you. I think that's it. I think with that we can just get it kicked off. We set aside 15 minutes for introductions, but it's okay if we take less time. So we've got a couple of folks that are going to give about 5-minute talks apiece. Simon, you happen to be first on our list, which means we were hoping you would not mind going first.
That's fine. I will start sharing my screen.
Great. And so we're trying to keep the presentations at 5 minutes each. I'm gonna set a timer and yank you off stage. Okay, thanks.
All right, so here is my talk. I'm just gonna go to slideshow. So Throughput is a graph database effectively. Sorry for the camera angle here. I shared the link for this presentation in the chat. And so there are a bunch of links here if you want to go and check it out. We're also going to be talking about Throughput in the next session in the data annotations section, where we'll talk about some of that. Basically, the idea behind Throughput is this recognition that data repositories exist within a continuum of activities. We talk about that in this article here that you can check out. It's very good. We really want to focus on these sort of 4 main issues with respect to doing research and specifically interdisciplinary research. Ultimately, and sorry for going really fast. Ultimately, Throughput is effectively an annotation graph. We use the W3C annotation model as the underpinnings. It's implemented in Neo4j. It sort of looks something like this, where we have a link between, for example, a scientific article and a code repository. One of the use cases we have is we've been mining GeoDeepDive to look for instances where code repositories have been referenced in articles. And we've created a bunch of these annotations. We identify the agent using ORCID. And we have some other metadata associated with that as well. I know that for some people, metadata is their jam, and so just wanted to let you know that we're taking care of that. We can build this model out, and it's very flexible. And so, for example, here is a subgraph within Throughput that represents the R OpenSci R packages and associated GitHub repositories. So these are GitHub repositories that actually use packages from our OpenSci that themselves have GitHub repositories. And so this is a way of tracking impact of different products, in particular here, software products. It allows us to understand a bit more the ecosystem of use for these products as well. Another application is here where we link data catalogs, for example, the Neotoma paleoecology database, to code repositories that use instances of that data, and then ultimately journal articles that rely on those code repositories. So again, we can get this much larger knowledge graph about how information is being used in the geosciences and more broadly in the sciences, both from the perspective of the actual data, but then also from the perspective of the code that is leveraging that data to perform some sort of analytics. This is, again, the model. You can see code repositories. These are the annotations that link them together, and then the data catalogs. The other piece of this is this understanding that data and knowledge about data is cultural. And we'll talk about that a little bit, but basically Throughput, by generating these annotations and linking these things together, allows information about objects within the graph and scientific objects that may be tacit to become more explicit and to be passed along. Using ORCIDs, we can also judge the veracity of the comments or the weight to which we want to assign individual annotations. And to go along with that, we now have this widget that allows individuals to connect to Throughput through an individual data catalogs platform. So they can basically connect to Throughput through, in this case, Neotoma or Linked Earth or EarthChem, and create annotations about individual data sets. with just a very simple HTML tag that then generates an annotation. It's accessible through an API as well. We link to OAuth systems through ORCID, but basically we're connecting a whole bunch of data to build a very large knowledge graph. And I just wanted to show you this. Boop. Oh, it didn't model properly, but basically I'll close that. So for example, here is a bunch of data that is connected to boop, individual node. These are all code repositories that are associated with the biomodels data catalog. This is just a subset of them. And one of the things we've been doing lately is fully using that graph to actually start looking at communities of practice within the online systems. So these are all code repository. These are all data repositories that are linked to a subset of code repositories that form a distinct community within the overall knowledge graph.
Great, thank you. All right, who do we have next?
Sorry, I'm trying to click stop share, but it's not stopping. So someone's going to have to.
You seem to have
take
stopped
over.
sharing.
Oh, okay, great.
I think you're good, yeah. Next up, we have Kyle Onata talking about Internet of Water.
All right, you're here. It's working. You'll see my slides.
Yes.
Okay. All right, so I'm Kyle. I am looking at this project called the Internet of Water, and I'll be talking about this project geoconnects.us, which I'm actually working with Doug on, and Dave Blodgett at USGS, which is about making a community knowledge graph for water science management policy. Right, the basic vision is connecting at least the metadata of primarily observed and modeled kind of water observation data in the United States, connecting users, producers, and aggregators of data. This is basically the operationalization of the Selfie project at OGC that Dave Blodgett from USGS led. Basically, the vision is we want people to be able to discover water data that's being collected by many different organizations without knowing ahead of time who they want it from. And we want to do this in sort of a web architecture way because we do want this stuff to show up in search engines. You know, currently, if you were to search for water data, you basically get views like this, dominated by USGS, not particularly granular or organized views of anything. We want to make the kinds of widgets that are possible with other kinds of information about movie times, about recipes, about weather. We want to make that possible for water-related data. So the four things geoconnects.us is doing is we want to catalog data from the community and make that data discoverable, and in particular with explicit reference to the stream network and the hydrography and the hydrologic landscape. So being able to tell what's downstream or upstream of what things. We want links to be persistent for all these resources. We want also to be able to infer semantic relationships and sort of traverse that. And we want to follow W3C spatial data on the web best practices. So just as an illustration of the kind of use case, we can imagine the Gold King mine spill was a disastrous, was an environmental disaster that happened on the Colorado River some time ago. And we want to be able to sort of quickly traverse a knowledge graph and be able to find, say, all of the water quality monitoring stations and stream gauges, and also find out who all is withdrawing water downstream of this contamination event. We want that stuff to be persistent. And then we also want to have both geospatial and semantic inferencing. So not just, we don't want to know just what's downstream, but who's withdrawing water downstream, even if that's not geospatially particularly related. Like this water utility gets water from here. We want to know where to find the drinking water quality data from those systems, and maybe process some census data that those systems are relevant to. So we're trying to set up a framework where semantic web resources can be published about two kinds of things: real world reference hydrologic features, so lakes, reservoirs, other points of interest like that, and then the organizational data sort of sources about them. So what that really comes to brass tacks is we need guidance to publish JSON-LD about persistently identified reference features. So like this, where you could have, I'm this ID, I'm a stream reach, I have this geometry, I'm in this watershed, some data about me. And organizations can also publish, I have data about this dam, which is about, or which is on this stream reach. And data about me can be found about particular observed properties and so on. So we kind of have an end-to-end architecture set up where we set up our own persistent identifier registry, which any organization can publish to, that generates a sitemap that we point a harvester to, which is just an implementation of Gleaner. So we work with Doug on that. We work with, currently working with a lot of federal and state agencies to publish landing pages with embedded JSON-LD that include or that incorporate template schemas and vocabularies derived from the Selfie project. We're primarily relying on schema.org, HY features, which is about hydrology features, and then SOSA and SSN for sensor data. The knowledge graph itself, we're going the RDF route, primarily because that's what we're working with JSON-LD, and we're using GraphDB primarily for the geosparkle capabilities because we're doing a lot of explicitly geospatial inferencing. And so it's kind of cool because we were working directly with data providers that we're kind of iteratively modifying how the JSON-LD is formatted, published, what vocabs we're using, and more of our use cases, going back and forth between those two to figure things out. So we're still early on, but our GraphDB is up and running, and I've done things already like inferred. Like I've gotten, these are all of the water utilities in a county in California, and then I can get to where their water quality monitoring data is, and also find the municipalities that they kind of serve. Just through geospatial inferencing. I'll share the links. I'll just share the entire presentation like Simon did. So, but we have lots of documentation sites as well. I'll stop there.
Awesome, thank you. Next up, Chantel Verhey. I'm sorry if I'm butchering everybody's names, from the Polder project.
Thank you. And don't worry, you did a decent job. I've heard it worse. Let me just pull it up real quick. Oh my. Can you guys see it just fine? Hearing no.
Looks good.
Yep.
Okay. Thanks, guys. So yeah, like it was said, my name is Chantel Berry. I'm with the World Data Systems International Technology Office, and I've been helping the Polder working group set up a federated search. So the Polder working group is the Polder's working on best practices and a federated search. So the best practices is utilizing the scienceonschema.org guidelines and creating a Polder specific subset of guidelines with schema.org. So we participate in the scienceonschema.org space. And sorry if you guys weren't made it to their session earlier, because it might be a little repetitive at this point. So we decided on schema.org because it is lightweight vocabulary that will help the Polder community with capacity issues. In the previous work package that I completed, we also worked on a schema.org primer. So it's a document outlining where schema.org came from, what is driving its uptake in research data management, how it works in broad strokes. And there's an outlining numerous initiatives that are working harness the schema.org and produce valuable resources for others to follow suit. It is currently under or waiting publication. So if anybody's interested in a document such as this, please feel free to email me. My email will be at the end of the presentation, and I'd be happy to provide the preprints. So the Polder federated search has been using the Gleaner harvesting tool to get our site up and running. So it is a Blaze graph database, and it is ultra high performance graph-based, supporting blueprints and RDF and Sparkle APIs. The graph database feeds a custom Python application. I'll show you the next figure, kind of to outline the app backend in the next slide. The Python application speaks to all components and makes it functional as a website. Originally designed to work with the Science on Schema, but Sparkle queries are written with our new Polder implementation of Science on Schema in mind. So we decided to go with this strategy because it is a super handy way to, when we get to actually implementing faceted searches. We're currently in the pilot stage, so we do have a site up and running. This project, the pilot stage is supposed to end in March 2022, and then we'll run it into full deployment and hopefully be able to add a little bit more search engine or search queries and whatnot. So this is the diagram for the infrastructure that we currently have set up. So we actually use a joint approach of the indexing data one, since they already have a lot, various Polder repositories that they are personally harvesting. So we didn't want to reinvent the wheel. We wanted to kind of meet the Polder community halfway. So we're using both Gleaner and then indexing data one. So you can see that we're trying to harvest from various repositories and create it into a single user interface. So as of right now, we have about 10 repositories that have either already implemented the Science on Schema guidelines, or have agreed to implement the Polder version that's coming up, and they will all be included into our pilot Polder federated search. So our goal is to have a tool that you can text search, basic date searches, basic spatial searches, and whatnot. Feel free to go to the link that's on the screen. I can pop it in the chat after and play around with it. If you notice any bugs, problems, comments, concerns, or have any suggestions, we are more than receptive to anything that anybody can share with us at this time. As it is a pilot, we're just trying to build it up as best as we can. So if anybody in this group is interested in participating or contributing to the pilot project, as of right now, we consult with the community at the Polder to Global Data Interoperability Hackathons hosted bi-monthly. Our next one is going to be February 7th. Everybody is welcome. You can sign up to join through the Arctic Data Committee's website. So if you have any questions, feel free to email myself at my email on the screen, or Melinda. She's our web developer, so apologize for my lack of technical knowledge, but Melinda would be more than willing to help when needed. And yeah.
Great, thank you so much. Tom Narok.
All right, so as you can see from the title here, so I'd like to introduce two graphs, again, just to give some more context about how these things are being utilized and some applications, but also to kind of highlight, in this case, two historical projects and how, now that they've run their course for a few years, to take a look at how initial thoughts about sustainability and governance have played a role in how these knowledge graphs have evolved to where they are today. Or in one case where it is no longer available today. So the first one was an effort in the NASA space science data environment with the goal of using knowledge graphs to aid in search and discovery. And we felt that graphs would support the high level discovery objectives, particularly the users had an interest in saying, I'm interested in a particular measurement type. And the thought was that a graph-based approach would easily facilitate connections such as, well, those measurements come from these type of instruments, which were aboard these spacecrafts, which have these data sets and are subsequently available for the time period that you're interested in. There was some additional inferencing and reasoning capabilities. And so this particular knowledge graph was implemented in RDF and AL and had a Sparkle endpoint and a graphical interface based over top of that as well. This particular project was very much a top-down kind of build it and they will come mentality. The user community wanted search and discovery. They didn't necessarily have an understanding or a want for graphs per se. And so the idea was that we'll fund search and discovery and we'll build a community around the graph and the system as we go. And just to give you a quick, data point here in the utility of this. This is one application to see, just start to quantify the utility of this. There was a study done in 2002 where authors spent a lot of time, essentially 2 work weeks, trying to manually search through all the data to find events that were relevant for their study. And we tried to use the knowledge graph to reproduce the data discovery portion of this. What we were able to show was that you can, what had normally took about 80 hours of effort could be done in roughly about 10 minutes using a knowledge graph. So again, it's just one anecdotal point, but it kind of highlights some of the utility of these systems. The second, second knowledge graph was an effort to take the historical AGU meeting data and turn it into a connected graph. Again, here we thought the graph-based data model fit really well with the interconnections between people, organization, projects, and a graph-based approach would facilitate easy discovery and connections there. This began more of a bottom-up approach. It was, interestingly enough, just a couple of people sitting around an ESIP meeting saying, wouldn't it be cool if we could do this? And trying it one evening and then pitching it later that Friday as a Funding Friday project, which fortunately was awarded. And then the AGU saw it and said, hey, that's interesting. We'd like to build this out a little bit more. Other groups at ESIP said, hey, we'd like to create an ESIP meeting graph as well and try to connect it to the AGU meeting as well. And so it was really a organic kind of bottom-up approach, which is quite the opposite of what the former graph was. And to give you some applications here, the top left is just a quick visual of folks who were new to AGU, who had a topic in mind that they were interested in, and the graph facilitated finding people who had given presentations on that topic and people they might want to seek out for collaborations. The bottom right was a look at collaborations between sections of the AGU and looking at how many people were presenting or collaborating across those sections. And so to kind of just summarize this very briefly in the context of the questions that Doug and Andrea were thinking about. So we found that there were a number of applications where a graph-based approach just kind of naturally fit the problem. And in those applications, knowledge graphs were very useful for user communities finding unknown patterns and unknown connections. They also help facilitate speed and ease of discovering data sets and resources. In terms of governance, the NASA project had a very well-defined regular meeting governance committee, which was helpful in some regards, but also meant that development and progress was very, very tedious and very, very slow at times. On the other hand, AGU project was a small group of people, very dynamic. I think they each have their pros and cons. I'm not sure that either governance model really solved all of the challenge. So I think there is, at least I'm hopeful that there is a middle ground between move fast and break things and the perfect being the enemy of the good. I'm not sure exactly what that looks like, but hopefully something does exist somewhere in the middle there. In terms of engineering obstacles and challenges, these projects have been around for a number of years, and the AGU project in particular used what at the time were the leading ontologies, vocabularies of the day. I think if you took a look at it now, you might rightly say it's somewhat outdated. In the ensuing years, a number of different modeling strategies have come along as well. And so one of the things I just wanted to highlight is that I think with the ultimate goal is that we want to all connect and integrate these different projects that are going on in different knowledge graph efforts. And in doing so, just to be aware of, they're often created under different methodologies and different ways in which they're implemented. Also, just because different knowledge graphs have the same entities or concepts within them doesn't necessarily mean that they're easily integratable. For instance, AGU has people in it. A lot of other graphs have people. However, the AGU data kind of predates things like ORCID. And so while we do have people and other groups have people, we cannot very easily say that they are, in fact, the same people. We also get quite a few requests for bulk downloading of RDF data, which I certainly understand. If you're implementing a project, you are reluctant to be beholden to other graphs out on the internet and sending queries to other places. However, there's also another factor to keep in mind is that we don't want to keep reinventing the wheel and just downloading and reintegrating the same data into other knowledge graphs as well. Sustainability models, ultimately, these were kind of based on hope and prayer, with the NASA folks thinking we could build a community as we went, and it in this case didn't work out, and that project is no longer around. On the other hand, I think these kind of small organic kind of grow as they develop type projects work really well. Although again, with the AGU, we are using someone else's meeting content and someone else's data, and so it is very much reliant on them continuing to want to offer the underlying data source. As we just to wrap this all up, there's been a lot of really great knowledge graph sessions this week. There was one on Tuesday, which is talking about a Earth and Space Science Knowledge Commons. As part of that effort, knowledge graphs would play a huge role in that, and they are currently soliciting essays to their pub space about all aspects of knowledge commons. And so if this two graphs presented here are of interest to anyone, we're going to submit a much more detailed essay on some of the choices that were made in those two regards. So hopefully in the next couple of weeks, you can find it there. And I will just leave these other resources if anyone's interested in about these two particular graphs. Thank you.
That was great. Thanks, Tom. And our next panelist, if I can get my notes to open, Sarah Lafia is going to talk about efforts from the Discovery Cluster, I think. Okay.
Yes, I am. Hi, everyone. Let me just share my slides. All right, so I am a research fellow right now at the University of Michigan. I work at a social sciences data archive, ICPSR, and I was the community fellow with the data discovery cluster last term. I'm currently with the semantic technologies cluster, and we're interested in maybe moving some of the work that we did in the discovery cluster forward in that space. But this is a great panel for that reason, just to see what's going on across ESIP. So today I just wanted to share a little bit about what we accomplished last term in the ESIP discovery cluster, and also maybe gesture toward what these knowledge infrastructures could support in terms of social science data researches, which is something else I'm interested in as well. So just an overview of the tool, which is linked in the notes. This is what the landing page for the usage-based discovery tool looks like. So one of the contributions of our cluster was coming up with a limited set of topics which could overlap that describe different earth science disciplines and themes. So we ended up with a set of about 20 different topics, which include things like agriculture and air quality, which describe data products. So the idea here is to build out this simple data model that links these earth science data products to research applications in which they're used. And so in this way, the interface shows possible data users, the variety of ways that data sets have been used, and they're integrated through the topics that they deal with. So the flow of the site looks like this. Users move from a science topic, which is defined at a high level, into an application or a research paper. That was a big effort we led last term, was to ingest a bunch of different scientific publications into the app. And then through these, we can see in the center of the display, there are different applications or, again, research papers in which the data sets were used. And you can see in this example, the facet is set to the topic of fire. So if I'm a researcher and I want to see who's worked with global fire data products, I can click on this and then see an example of an application that uses two different data sets, the urban extents from VERS and MODIS, and then this VERS data product. And then these links will take you out to the actual data product. But in this way, it's a pretty simple data model, but I think it's pretty effective. And we've been building it out from community efforts as well. So yeah, I think we had two different sessions that were more of a hackathon style effort to classify research articles. And the tool also includes a way for you to log in with your ORCID and then contribute annotations to the platform, which is kind of nice. So you can see, this is really mini, but you can see on the leaderboard here, my contributions are highlighted in green. So I added 16 relationships to the database, which is not that many, but these things take time. And you can see the spreadsheet we set up as well for this activity, which was just labeling articles based on first finding articles that use earth science data of any kind, and then assigning a number of different topics to them so that they could show up in our app. And this is just now there's so much in there, it's a bit of a mess in terms of the visual, but this just gives you an overview. All the blue nodes are research articles and they're linked through their topics to research data products. So those are shown in red. And these are just some examples of the types of research papers and data sets that are currently in the interface. One thing that we've, I think some great feedback we received from our last session was there seems to be a lot of energy and enthusiasm in this area from different efforts like the Coleridge Initiative and also other agencies that are leading this discovery effort. And I think there's, up to now, it's been a pretty manual effort just to build the tool and as a prototype, but I think the next steps for the cluster might include trying to automate some of the ingest and then the classification of topics too. So I know colleagues like Chris Linus, who's been leading this, and others in the cluster are really interested in going in that direction. And just to wrap up, my connection to my research is I'm just came across this GASIS research graph, which is really cool. This is one of the largest European social sciences data archives. And they're building out a linked data representation of their research products, which is being used in a bunch of different ways. And it seems that this is also supporting their research data discovery efforts and recommendation applications for research data, which is something I'm starting to study at ICPSR as well. So I put a link to this in the notes too, because this was new to me. And I think it would be really cool to try to integrate some of the ESIP efforts with bigger initiatives in different disciplines like this. So that's it for me. And oh, and also the application I'm specifically interested in is, in addition to recommendation, we'll be able to better understand metrics. So like the impact of research data and helping data producers and reusers understand communities of use in terms of their disciplinary impact, as well as if, for example, your research data set is being cited in a highly influential publication, that might be nice to know. And so I see knowledge graphs as one way toward that. So that's it for me. Looking forward to the discussion. Thanks.
Thank you. That was great. And last but definitely not least, Doug Newman.
So I don't have any slides, so I'm just going to introduce myself and what I'm responsible for in this sphere. I'm Doug Newman. This week I am the system architect for NASA EED's Search and Discovery train. That covers things like the Common Metadata Repository, Earth Data Search, and Earth Data Login, which some of you may be familiar with. Within the Common Metadata Repository over the last couple of years, we've been putting into practice a knowledge graph to aid with search and discovery, particularly in the area of relevancy. And it also serves as a technological solution for several areas which we've been solving using more traditional relational databases, which weren't an ideal fit for the problem we were trying to solve, but graph was. So we're going to start migrating that functionality into that graph. And as a consequence of that, leverage that information for other things as well. Sarah, if you'll indulge me, can you go back to that slide that you referred to as a mess? Can we do that?
Sorry, that probably wasn't the best choice of language, but yes, let me find it.
So while she's doing that, I'll keep talking. CMR is a cloud-based service right now using Amazon Web Services, and our knowledge graph is implemented in AWS Neptune. That afforded us a managed service, which we didn't have to worry about, which made it very attractive to us. The other thing that was really attractive about AWS Neptune is it provided standards-based APIs, both for Gremlin and Sparkle. So those were the main driving forces behind the adoption of that technology. We wanted a standards-based approach, so we could do that. If we build it, they will come. A goal that Tom talked about. All right, so this is a mess, Sarah is correct, but it's a beautiful mess. Whenever I see one of these things, I'm like, what's going on here? What happens if I expand on this area? And that's the knowledge that I'm really excited about. As an engineer, I can infer some amount of knowledge out of that, and we did that for the primary use case, which we launched graph technology on, which was as an Earth Data Search user, I should see collections that are related to my currently selected collection. And when I started putting aspects of CMR metadata into the graph, I could see these relationships from one collection to another through commonalities, like they share documentation or they share a URL. And that was wonderfully visualized on something exactly the same as this. I think we even used the same underlying technologies to present these pictures. Now, if I can do that as an engineer with not a lot of background in earth science, in engineering, yes, but science, no. I wonder what a scientific community could do with this kind of visualization and these kind of tools. And that's what I'm really excited about in this sphere. We can use, as an engineer in NASA EED, I can use this to solve some technical problems associated with CMR and Earth Data Search. But if we expose APIs and tools that let different audiences get into this these relationships, they can extract knowledge that we didn't even think of and use it in a novel and exciting ways that can do wonderful things, hopefully. So this is not a mess. It's a beautiful mess to me, and it's very exciting. And that's all I have to say, unless there are any questions.
I think we can start opening up questions in general. Very philosophical ending, by the way, Doug.
Yeah, that was great.
So you know, we're going to start looking at the Slido questions. We have some good questions in there. If people want to ask, though, I don't want to disrupt the interactivity of an opportunity like this. It's always nice to chat with people and hear people's voices. So if you have questions, go ahead and raise your hands, and we'll try and call upon you. We'd like to preference that over Andrea and I talking and asking questions. So I'm going to give a few seconds for people to.
I can, yeah, like while people are thinking of what they want to ask, there is like one general question I want to kind of kick us off with. So for basically all of the panelists, what do you see as the biggest challenges in this space in working with knowledge graphs? What are the biggest open research questions or engineering obstacles?
Doug's on it. What do you got, Doug?
So even though, as I mentioned, it's early days with our knowledge graph, and we at the moment we're just creating our knowledge graph entirely from metadata records that are in the CMR, UMC records for collections, services and tools. Already with usage-based discovery, I can see a need to be able to reach out to that graph and grab aspects of that. Currently, the only solution I have to that is to consume that graph into the graph we have in CMR. I'm already thinking about how we can solve federated graph traversal queries. Kind of the same problem we had with just vanilla search that the discovery cluster at ESIP very successfully solved with federated search. Particularly with OpenSearch, I think there's the same kind of problem with graph traversal. However, because it's not the traditional problem we're used to, I think Andrea alluded to this earlier, we're all very familiar with relational databases and how you query those, but graph traversal is quite new and, in my opinion, very exciting. But how we do that in a federated way, unless you guys know of anything, seems to be fairly undefined and unknown at this point. So I see the potential for a lot of silos here, and we need to connect. Well, ironically, we need to connect them. And how do we do that?
I think that's a really good point, especially given that some of these graph approaches are intended to like traverse silos, and you don't want to create another silo of things connecting silos. So
yeah, and we don't want one big silo either.
yeah,
Really.
yeah.
Right. Yeah.
Kyle,
Any
you
other
unmuted.
panelists wanna bring that up?
Yeah, I mean, I was just going to echo that. It's something Dave Blodgett always says is the semantic web is essentially used offline. I don't think anyone has cracked this nut.
Kai, did you want to say something?
Yeah, sorry, I was going to jot it down in the chat, but if you don't mind, I'll just throw out
Please
my
do.
thoughts here. So just in response to that question, just a really quick thoughts on that. So into silos. So one, shared vocabularies, or at least harmonized or mapped vocabularies that, people can, across communities can agree on, or at least the vocabularies connect to each other. And then two, people who do expose their data to something like a Sparkle endpoint also expose the instructions on how to query it in their system, and just have that kind of be a standard practice. So maybe, because my experience working with graphs is it's always like a little bit different, how to query everyone's system, et cetera. So if people can use consistent vocabularies, at least map ones, and then expose, how to get through it. Very simple stuff, but maybe it's a start.
It is. I think there is some additional friction involved sometimes when you have people who are using, Neo4j or property graphs, where the application of RDF-based vocabularies probably isn't quite as natural. I mean, it's not impossible in those environments, but maybe isn't quite as natural. Charles, you had your hand up. Okay.
Yeah, I mean, I don't want to give a complete spoiler to the session tomorrow, but I will talk a little bit about some approaches from the life sciences community in using sort of a Wikidata centric sort of crosswalking, right? So, for example, I put in the notes Wiki Pathways, which is a project to document biochemical pathways, and they have a federated Sparkle query that also includes PubChem and crosswalks to the gene ontology and crosswalks to Wikidata, right? And so you can query all these resources essentially as a common thing. And they have lots of examples. So the real issue is, how do end users know how to, even begin doing this sort of thing? How do I do a federated query in Sparkle across, different resources as a service request and know that, I'm going to get a meaningful result? And so they have a bunch of examples of, basically taking a PubChem identifier and then pulling an INCHI key, which is a string chemical representation from Wikidata, which wasn't there in Wiki Pathways. And so it's not easy. They did a lot of thinking as a community about where things should go and how to build the crosswalks, but there are communities out there that are doing this. So, and that's, if you're a little bit more interested in that particular sort of use case, the Wikidata as a knowledge graph for the Earth Sciences plug for tomorrow.
Great. Simon Goring, I see you had your hand up as well. And also I might note that there's a question for you that's tangentially related to this from Ryan, which is mechanisms or projects to connect to Throughput. So it's kind of tangentially related.
So I guess, and maybe that's also tangentially related to the point I was going to make, which is a separate challenge that I think we face, which is that oftentimes these connections and these crosswalks happen at a time point and are effectively static. But if you're reaching out across a large number of data resources, metadata standards within those resources or the metadata content, depending on how it's being served, does change over time. And so one of the big challenges I think we're going to face as we go through time is how we treat that relationship between the knowledge graph and the resources upon which they draw, how we keep those updated as user needs change, either from the perspective of that federated resource or the individual resources, and how we maintain that kind of leadership or administration, I guess. Who is responsible for the standards, who is responsible for making sure that the individual groups follow those standards, and how do we maintain that in a sustainable way in the long term. And then I guess quickly to answer Ryan's question, right now we are largely in a pilot phase, although we have quite the central infrastructure is largely developed, but I think right now we're sort of in these one-on-one communications with groups to try to better understand how other knowledge graphs can connect. We do have an open API system, but as far as like searching and connecting in a more integrated way, that is still something that happens through direct communication, and I welcome anyone to reach out and chat. So.
Great, thanks. Doug, you wanted to comment?
I just wanted to restate that ESIP as an organization has form in this area. They were very successful in cracking the nut of federated search, as I mentioned earlier. So I have confidence in our ability to do that again. That's all I wanted to say on that.
Sounds like you want to lead a cluster associated with federated.
For this week, I don't know. All bets are off in 2 weeks' time. Yeah.
So there's a popular question in Slido, and I think I'd like to kind of ask if anyone on the panel. I think it was a situation of, there are different graph approaches, right? In terms of query, if you just look at it from query languages, you have things like Cypher, you have things like Gremlin, you have things like Sparkle. And I was curious if anyone on the panel, first off, switched between any of those or evaluated different graph implementations and could comment on any pluses and minuses they had about different implementations of graph environments, or whether you all just kind of fell into the one you used initially.
Is it okay if I pop in quickly?
Yeah, of course.
I did put up my hand, so.
Oh, I'm sorry.
No, that's fine. Whatever. I mean, so I use Neo4j. I'm much more conversant with Postgres, which does now have network packages that do support sort of graph networks. Part of the reason I settled with Neo4j is that the documentation was really clear. I started out, Doug really talked a lot about Sparkle, and I sat down and tried to learn it and threw up my hands and basically said, I have no idea what's going on here. And so I do think that some of it is just that is the learning curve where people are coming from. I think that now that I've done a lot and I'm much more comfortable in the graph space, part of me thinks, oh, well, maybe something like Neo4j is not the best choice, but there's technological buy-in as well. And there are like plugins now for Neo4j that work with Gremlin and stuff. And so, yeah.
Any other panel members want to chime in on that one?
Yeah, I got my hand up, Doug.
I see that.
Seeing that?
Yeah, I see that.
So I have 2 minutes and then I'm going to jump off and jump back on again in 5. Okay. So what I wanted to say about the choice of technologies, APIs, etc., because CMR were in AWS cloud space, there was a managed service called Neptune. We needed that scalability. We needed that reliability. So we went Neptune, and that gave us 2 options for a query language, either Sparkle or Gremlin. Now, when I talked about that beautiful mess, you visually look at that and your eyes navigate through it. And Gremlin gave me that at an API level. I was able to, it was intuitive to me. Sparkle wasn't. That may just be me. I found Cypher not very intuitive as well. And there's a very good tutorial on Gremlin about using a knowledge base, a knowledge graph on airports. Basically talks you through the API, and a lot of the use cases on airports, how to get from this airport to this with the fewest number of hops and things like that, seemed that they could map into our domain space, things like that. So that's why we ended up where we were, and I will be back soon.
All right. Chuck, you had your hands up?
Yeah, just a comment. We use both. So the answer is, oh, well, actually all the above, but mainly Sparkle and Cypher. Some of the limitations, so Cypher is really good for beginners. It's really good if you're using labeled property graph model. It's really good if you want speed, but there's things missing from it. So I can't necessarily do constructs in Cypher, although that's being fixed. So they're doing extensions as they know that they need to add things like procedures and construct statements and time-centric. There was a paper out from the Neo4j folks in archive a month or 2 ago on event-driven querying using Cypher. And those things are sort of converging in GQL. So I wanted to make sure that there was, I added the link to this effort that is to create a sort of a new standardized, yet another standard graph query language. But it is, looking at Cypher, it's looking at Gremlin, it's looking at Sparkle to see what the common sort of requirements are and trying to bridge those gaps. So, I think there is some recognition that there's advantages in one language and disadvantages in other languages, and trying to move toward some commonality and convergence there. So, either depending upon your point of view, that will complicate things or make things easier. But I think it's kind of hard to build out systems in, at least from the sorts of machine learning things we've been playing with, in just one language. Because there's resources in RDF and in Sparkle endpoints in some places, and you may be moving that into your own enterprise knowledge graph sort of system, which would then, could be either, if you're in Neptune, it could be a Gremlin system, or it could be a, Cypher-based system if you're using Neo4j. So.
And thanks for adding that link into the resources section.
And also Neptune now supports Open Cypher also, I believe. So you have 3 options now, I think.
And I think Ryan mentioned that in the chats. Ted, you had your hand up?
Yeah, thanks, Doug. Charles mentioned it in passing, but is anyone else using GraphQL?
So I think. I mean,
Yeah,
Graph-
we,
Go ahead. Go ahead,
I
Ken.
was going to say, yeah, we are, but we're using it as API. So we have some projects that essentially are building an application layer. And so we use that as subsets for the application layer, but GQL has some, it's not a true graph query language, but it's really useful for building out based upon validate. I mean, so the nice thing is that it has JSON schema behind it. So you can build out a application layer that can query subsets of the graph. But it's also missing things in terms of graph traversal and other things in terms of what Sparkle brings. So the answer is yes, it's part of the mix, 100%. GQL and graph and is a little bit different, right? It's than GraphQL. So just want to make sure that one is a sort of a standard that is a replacement for OpenCipher for all these sorts of existing query languages that are interoperable in some way. And then GraphQL is sort of a graph API layer that could sit beside it for an application layer, if that makes sense. At least that's how we've been using it.
Thanks, Charles.
Andrea, did you have a question you wanted to promote up?
I do. I'm taking moderator's privilege in this. So partially because my PhD is in library and information science. A really big area of research in the information sciences for a long time has been information seeking behavior. In my school, there's a ton of people that do user interaction, user interface, user experience research. So I'm wondering if that is on people's radar and if people are thinking about end user interaction with these graphs, whether it's through a beautiful, messy diagram or through an API or something like that. So I'm wondering if people have thoughts on that.
So I do think, again, this is a challenge. Oh, sorry, go ahead. People had their hands up and thumbs up.
Go ahead, then I can go.
I guess I was just going to say, I think that those of us who are designing these systems have ideas in our heads about all the potential that they have. And I don't know if that necessarily has connected with the community at this point to such a wide degree that they know how to directly interact with the graphs. They can interact. Yeah, that's it.
Kyle, did you want to talk about that too?
Wait. Can I quick follow up on that, Doug?
Please, Mark.
Sorry, this is Mark. Why we don't necessarily want the users to interact directly with the graphs, do we? I mean, I think that's how what I was interpreting Andrea's question was. It's a user experience question.
I think my question is, do we? Like, I could see there being argument and if we have data on if users need to or want to. I think that's where I'm going. Yeah.
Okay. So does that change your answer, Simon?
No, I don't think so. I guess part of my motivation for that answer is thinking about the fact that ultimately these knowledge graphs belong to everybody. And it would be great if more people could build applications on top of that to take some of that work out of us. I mean, that's one of the promises of open science and open data. And if we don't fully understand how people can work with these graphs or how people might want to work with these graphs, then we're potentially missing a huge audience for them.
Okay, so we want to do that, but then we also want to enable different people to build different interfaces on top of the graphs, which may be obviously graph oriented or may not be. You know what I'm saying?
Yeah, I think of those as users as well.
Okay, all right. Sorry.
No, that's good, Mark. So I might take moderator's privilege again and get a new voice in here. Melinda, can I address your hand?
Oh, sure. Yeah. Can you hear me?
Yes, fine.
Okay, great. So before my life as a Polder web developer. I did some work in the data visualization space and in a little bit of user interaction design. And to address this question, I would say that it really depends on the goals of the users that you're trying to support and what they want to do with it. So if you're somebody who has a big bag of data that's represented in a knowledge graph and you're struggling with how to interpret it or present it, then yeah, you absolutely do want to be able to explore it in a way that is very natural and open-ended. And you might be doing that in order to figure out how to present it to people who don't know as well what they're looking at, which I think is something that Mark was alluding to. Like, do you actually want people to look at this thing? A couple of good precepts that I think are really applicable to this kind of thing where it's very large and can look like a big ball of hair once you're looking at the whole thing, is that the user should never be lost. You should be able to zoom in and zoom back out, or drill in some way to examine relationships and drill out. So I think that uses of clustering, of aggregating visualizations are very applicable to this kind of thing.
Melinda, do you think we have the libraries and packages that allow us to do that right now, or do you feel limited when you're trying to do that kind of UI development, UX work?
I think we do. It's just a lot of work, and it's not easy to put together just like that. It's not something that works right out of the box. You want something like D3 or something that's like custom software development, which, you know, for me, I'm like, oh yeah, you can do that. But for people who don't do software development, you're like, whoa.
Well, it's good we know you then.
Thank you.
Kyle, you had your hand up?
Yeah, I mean, for us, where we're dealing often with sort of non-research data, right? It's government agencies with real-time data who we're asking them to change fundamentally things about how they present data to the world on their web architecture. And this is sort of a public goods problem where the benefit of them doing this can be great for everyone, but but the benefits are diffuse and the costs are concentrated to them. So I think the apps sort of thing is actually super important when trying to build a community like this, because what's in it for them? They're going to want to see something like kind of soon if you're asking them to do this. So I think at least we've come to the realization that even if it's however simple, if we're going to ask people to publish data, we're going to offer up some little app that interacts with the graph that enriches their own data.
Great. Ellie, I see your comment. Please feel free to unmute and ask or present your thoughts.
Thanks. Yeah. So my name is Ellie, and I'm the former head of community at the Knowledge Graph Conference. And so I've had the luck to talk to a lot of different people building a lot of different kinds of graphs and apps. And a few things come to mind. So, you know, there's of course actually directly looking at a graph, which is sort of what it sounded like Melinda was talking about, and even maybe Simon as well. And there's a lot of tools out there for doing this, which are kind of hard to find and so on. But KGC, the Slack community itself, is a good place for asking about things like that, those kinds of resources. In terms of apps, so, you know, there's, at the end of the day, a graph is really just a bunch of connected data. And so you can build any kind of app with any kind of user interface that, you know, hopefully takes advantage of the features that graphs enable. But, you know, I've seen all kinds of web apps that you would have no idea are run by a KG just because they, you know, there's nothing different about the UI. But when you think about, you know, sort of what are the capabilities that a knowledge graph allows you to do that you would want to incorporate, you know, I've seen a lot of KG sort of like search bars on the government websites, and it's, you know, there's all this stuff back there, right? There's 43 repositories, for example, but you have no idea what it is and you're still sort of searching blind. So I think, especially to answer the original question, which is about information science, we want to think about how we can help users to navigate into sources of information that they're not familiar with. And one of the graph-based apps that we're all very familiar with is Wikipedia. which exactly does this through the linking, right? You can get onto all of these different topics that are intersecting behind the scenes within the graph because there's links directly to them. So, I think that there's some spaces for just thinking about typical UI flow and sort of what makes a good experience for a user generally. And then there's also more specific kinds of explorations that can be done for the unique features of knowledge graph enabling.
That's great. Thank you, Ellie. I don't know, like part of my reason for asking this is because I think that this is an important part of this puzzle for really supporting like adoption of these and getting a better sense of the truth, like the further utility, like pushing some of the projects forward, seeing people interact with it and facilitating that interaction.
So we did have a question that got upvoted in Slido for Tom, in particular with the AGU graph, and they were wondering kind of what AGU is doing with that graph now, or what its future might be, I think.
So AGU is still supporting it. It's part of their historical abstract division, which means a few months after the fall AGU meeting, so typically around March or April of the following year, we'll get an export of the previous AGU meeting data, which comes from AGU's contractor, and then we'll go through the process of converting that into RDF and AL and updating the knowledge graph. So it is still an ongoing project. I know previously some people have asked about it would be really useful to do this like real time and something we could leverage during an AGU meeting. Fortunately, they're not currently interested in supporting that, so it's a after the meeting kind of historical effect. They did have an interest a few years ago. They ran a small contest creating visualizations and kind of touching on some of the things that were just discussed about different ways of interacting with the graph. But there was a lot of really interesting efforts that came out of that. But as far as I know right now, it's just a very basic UI into the graph, and that there's no AGU hosting of those visualization and exploration resources.
Great, thanks. Doug, I see your hand up, but there's a question I wanted to direct to Sarah first that was coming out of the question. So actually there was two of them, I think, in here. One was it was hard to get people to annotate things in a way that conforms to standards. Do you have to go in and clean up after the fact? So with the annotations, I think, in regards to the annotations.
Yeah, for the discovery cluster, I think that was mainly, it's the way, I think it's a bit of a bottleneck, but it was also like a validation step. So the spreadsheet from the event was one thing, but then getting the triples into the tools done by the developer, for example. So that's, I think more could be done to check those, to review the labels, especially with regards to, another thing was just the assignment of topics required people to dig in quite a bit to beyond reading the abstract of a paper, you kind of need to be able to spend a bit of time skimming over it and thinking about which topic or topics are relevant to like label that document. So it's pretty time consuming. And at the event, different people had different levels of familiarity with a huge range of different earth science topics that we were trying to get them to label. Like people have, different disciplinary experiences. So that was a little bit tough, but I think the point of the topic labels especially was to train a machine learning classifier to help with that task. So I think there's some hope going forward that process could be semi-automated, but that's kind of a fun open area of exploration right now.
Great. And actually there was another question for you too on the utilization of PIDs like ORCID or others. Are those how do you leverage those in the work that you're doing?
That was a cool idea that Chris and others integrated into the tool. So it works similarly to the ESIP website where it's a wiki model, so you can log in with your credentials and then you can make pretty much any changes you want as an authenticated user. And the same is true like in terms of the contributions. So that's how the leaderboard function was implemented. And I think that's, at least that's one way to keep track of people's contributions to the community, and also a way for the team, I guess, to filter out, or kind of let's say that certain label assignments might be more or less credible, or decide how to review them and so forth. But I think that's kind of how that functionality was envisioned.
Great, thanks.
Hey, Doug.
So yeah, Doug, go ahead, and then I'm sorry, was that you, Ted?
Yeah,
jump
that
first?
was my question for Sarah. And I didn't write it very clearly, but yeah, I was asking. There's something called the PID graph, which is a graph which has been created by DataCite and Crossref and ORCID. So it brings together all of the DataCite. There's 27 million data sets in DataCite, or 27 million things, and 190 million things in Crossref, and quite a few useful ORCIDs. And there's something called the DataCite Commons, which is an interface built on top of a graph that's created by those three organizations on top of something called event data. So event data is, I think it's probably a graph of whenever a DOI is mentioned anywhere in one of those organizations, or in a tweet, or in various social media channels, that mention is an event that goes into the event data, and the PID graph is a graph on top of that. So it's sort of prompted by Sarah. But for anybody here, is anybody using those resources? And I think the same is true. Wikidata falls into the same category, and maybe the Google Knowledge Graph. These really the big global infrastructure graphs that are being built.
Ted, did you put those references to those in the notes, or could you?
Yeah.
Good.
Yeah. So Throughput uses PIDs. We use ORCIDs. We use DOIs, both Crossref DOIs and DataCite DOIs. I think one of the big challenges that we've found, and I think this has come up in some other talks and other sessions, is with respect to the links. So for example, like in the Crossref metadata, or in the DataCite metadata schema, there's like referenced by tags, is that a lot of these fields and Crossref fields as well are dependent on the contributor. So whether that's generally the publisher or the metadata owner, and a lot of those aren't filled in. And so what we've found is that quite often with Throughput anyway, we're actually building more connections where connections hadn't been before. That's one of the use cases. We had talked to Shelley Stahl about that a little bit, just saying like, yeah, we can go back through and use something like GeoDeepDive to start doing this retrospective examination and build out that PID graph. But it's always a case of, you're only as good as the metadata that you have. So.
No, that sounds good. And Doug, thanks for your patience. You've had your hand up for a while. Please.
Hey, so I rejoined when I think you guys were talking about suitable tooling for graph technologies. Was that what you were talking about? How
right,
to
interfaces and things
right,
like that.
yeah. So I think the last time that I talked to the late great Peter Fox was on this subject, and he said, and I quote, so brace yourself, because we all knew Peter, the tooling for graph is crap, but the tooling for network topologies is awesome, and they're basically the same problem. So if you're having problems with finding suitable tooling for your graph implementations, then you might want to look at what's out there for network topologies. And sorry to rewind a bit, but you can't miss an opportunity for a good Peter Fox quote. So there you go.
No. Thanks for that. Let's see, Kyle. Okay.
This might be an issue that's unique to us, but maybe not, in that we sort of need folks to mint PIDs for very, very numerous objects. And, you know, so an organization might have 600,000 wells that they keep track of and want PIDs for all of them. So DOI is not it's just cost prohibitive. So that's why we've had to set up our own PID server, but it is worrying in what we're taking on and maintaining that. Wondering if anyone else has had to deal with anything like that.
So Ted, is your hand still up, or is it?
Yeah, well, I mean, you know, even though you need people to mint DOIs for lots of things, and it's cost prohibitive, somehow Crossref has done almost 200 million of them, and DataSite has done almost 30 million of them. I agree with, I agree that the relationships in those metadata could be improved, and obviously the use of ORCIDs and RORs in those metadata can be improved, and that's something that I'm working on. But those are, you know, we need to find a way for the science agencies and groups to plug into the big picture, rather than we saw a bunch of, you know, little project, or not little, but sort of siloed knowledge graphs demonstrated here. And I think that in the future, if this whatever non-cluster continues, I think it would be very interesting to have a session on, you know, using the Google Knowledge Graph, or using Wikidata, or using DataSite Commons, because that's, in my opinion, I mean, those are projects that I'm working on in trying to, you know, improve the metadata, but that's the game. It's not, you know, some small, you know, institutional repositories have the same problem. They have institutional repositories and they believe somehow people are going to find things there. But, you know, these siloed graphs that we saw are interesting, but there's a big picture of graphs out there that this group should probably explore and connect, you know, help connect ESIP to.
Right. Well, and leveraging off that, and also leveraging off Doug Newman's belief that ESIP can rise to this challenge, and we're closing in here at the end of the session. I mean, are there, you know, do people feel that there are existing clusters or committees that might be able to try and, you know, help us as a community come together and address some of these types of questions, the interconnections of graphs and knowledge graphs and elements like that? Are there some actions that we can start taking within ESIP?
It seems to me to sit between discovery clusters and one of the semantic clusters that we already have. However, discovery clusters kind of morphed into a special case with usage-based, which oddly enough is based on graph technologies anyway. But yeah, I don't see any problem in spinning up a new cluster, but I've never done it before, so maybe I'm just naive.
Chuck, you want to come?
I was going to, can I just answer? Spinning up a cluster is super duper easy. You would send an email to me with your justification, and then we'd talk about it. We'd bring Megan in on the conversation a little bit, and then pretty much you'd go forth and cluster. So
yeah, spinning up a cluster is easier than keeping a cluster spinning in some cases.
Yes, very, very definitely. Very definitely. So
as someone who spun up a cluster and then tried to keep it alive for a while, I can attest to that. But you know, I think I don't know if Mark is still here, but you know, I think discovery is an interesting idea. I also think sort of citation and connection. I mean, these graphs are connections of citations. So sort of the I can't remember the current name of Mark's cluster of research object something. Maybe it's a little bit broader, but that might be another one to bring in. Mark, go ahead.
Yeah, so I'll chime in. Research artifact citation. We call it artifacts as opposed to objects because research objects has a particular meaning in some communities. But the idea is that you should be able to reference and credit any worthwhile artifact in the scholarly universe, research data universe. And so that very much gets to persistent identifiers. And so I guess I just sort of want to double down on what Ted was saying is that, yeah, I think silos aren't inherently bad, as we're seeing in the conversation, that they're developed to meet a particular need. That's great. And we need to keep doing that. And I'd like to hear more about actually how we're developing knowledge graphs, what the methods are there. Another quote of Peter Fox is, "It's the methods, stupid." But how we use persistent identifiers in this is really critical. And as we develop our little silos, we can still interconnect those silos through these broader graphs like Ted is talking about. And we do that through consistent use of common identifiers. So DOIs are the ones of choice, a one of choice in the scholarly publishing world for data and articles, but there's others as well. And so we just need to start tapping into, I think, those broader graphs as we're developing our cool tailored graphs.
Thanks. And Andrea, moderator's privilege here as we close in.
Yeah, well, I wanted to speak to the cluster or to cluster or not to cluster. I think Doug and I talked about this when we were organizing it, thinking like we don't want to start a cluster because no one has capacity to actually lead a cluster or keep it going. But we could do a non-cluster that commits to meet every ESIP meeting or something like that. I think we have capacity for, getting together and talking twice a year. And if things emerge, then maybe there could be individual projects that spin out. So I just wanted to add my 2 cents there. I think that if we are there's enough momentum and enough projects going on in this space, I think we could keep trying to meet during each meeting.
To the host, can someone save the chat at some point soon before we go away? And
yeah, I think
stick
Bar
it
will
on
get
the
that
notes?
for us.
Great, thanks, Bar.
Chuck, you had something you wanted to add?
Yeah, part of this leads into a conversation tomorrow, also on whether the cluster or not the cluster. My feeling is that there's overlapping between enough activities that essentially would cover what a cluster would do with knowledge graphs. I think there's a bigger question of how to start connecting these between the Semantic Tech Committee, the harmonization cluster activities in terms of connecting Suite and Invo, and potentially Wikidata. So we're going to have some examples of that tomorrow from Gary Bird Cross. So I think that part of the conversation is not just to cluster and have another meeting, is to maybe there should be a discussion amongst clusters to see if there's aspects in each one that then could be a collective project that showed the benefit. So that may be another approach. And that's an approach I'll probably be pitching a little bit more tomorrow. But anyway, that's
a good way to
Charles,
close.
does that mean we need a cluster graph?
We do. Maybe
no,
that
no.
would be a nice ESIP fellow project, is to start.
All right, you two. So.
Well, and this is one thing we didn't quite get to talk about, but one of those joint projects could be around guidance for implementation. And I don't know if there's ESIP best practices or things like that. We've alluded to some of that in this discussion of PIDs. And I think maybe, I don't know, thoughts around siloization versus not siloization. So I think that would be a really rewarding conversation to keep pushing forward. And a lot of people would find that useful. There was one question in the chat saying, are there resources for those trying to get started for knowledge graphs? And I think pulling those things together would be great. So.
Yep. All right. I think that's a fantastic way to bring this to a close. Thank you so much to all the panel members. These have been some really wonderful conversations. I super enjoyed this. So, and Lindsay, you.
Oh, that's just from Susan earlier. I think she's gone now, but ESIP is currently moving to a new community database and really interested in the way that knowledge graphs, might be able to help map expertise and such. So just right in line with what you guys were saying. So hopefully
Sweet.
further conversations.
Sweet. All right. So Andrea, do you have any last minute?
Nope, just thanks, everybody. This was great.
This was great. Thank you so much to the panelists and all the people who attended. And Bar, will you be
Thanks.
able to capture the chat?
Thanks,
Anything?
guys.
Yeah, I'm just currently copying and pasting it, but I think I can save it so it's better represented later. But right now it's just a dump of text in there. So
All right.
it's there. Hopefully will be prettier in a minute.
Sweet. Thank you so much.
Bar, as as an ESIP staff person, as an ESIP, I kind of like the idea of getting a Slack channel together, because like I think that's low stakes interaction. Is that it? Can we just like make one?
I love that. Yes, I think I believe anybody can just make a Slack channel, but if not, let me know and I can just spin one up.
Okay, cool. That's awesome.
Yeah, and if folks aren't on Slack all the time, I don't hesitate to say, please do get on there. But that's a lot of
I know.
I think they're
Who's
spinning
not
up.
on Slack 24/7?
I know. I wasn't until this job, but now I get it.
Slack is unfortunately not accessible for people who use screen readers. There's
It is not.
someone which really sucks. Like, so there are some issues with it. But it is in some ways more accessible than email from a being able to read lots of things perspective. Yeah. Tom, thanks for sharing the stuff on the AGU graph. That was cool from like a science of science perspective. So it was neat to see you working on that.
Yeah, thanks for having me. This was really fun.
And Ellie, thanks for the tip on the save chat. I just did it.
Yeah.
Thanks.
We're done. I have to teach in an hour.
Thanks so much, Andrea.
I'll see you guys later.
Bye.
Bye.